Welcome back for another deep dive. Today, we are going to be looking at something that's probably powering the very device you're using to listen to this right now.
Oh, yeah.
The mighty GPU.
Ooh.
It's not just about gaming anymore.
Right.
GPUs are behind everything from those crazy realistic special effects you see in movies to the AI that seems to be everywhere these days.
Yeah.
So we're going to break down exactly how these things work using this really cool explainer that I found online.
Awesome.
You ready to get a little geeky?
Let's do it. I think a lot of people, when they hear the term GPU, they kind of just, their eyes glaze over. But it's really fascinating stuff once you peel back the layers.
Totally. Okay, so first things first. What exactly is a GPU, and how is it different from a CPU? The thing we always hear is like the brains of the computer.
Yeah, so the explainer uses this chef analogy, and I think it's actually pretty clever.
Okay.
So imagine the CPU is like a master chef who can handle all sorts of complex dishes, but kind of one at a time. They're really good at multitasking, but there's a limit to how much they can do simultaneously.
It makes sense.
The GPU, on the other hand, is like having a whole team of line cooks, each specializing in a simple task, all working in parallel.
So like if you needed to chop up a mountain of vegetables for this giant feast,
Yeah.
the line cooks would be way more efficient than the master chef trying to do it all on their own.
Exactly. And that's really the essence of parallel processing, which is like the GPU's superpower.
Okay.
So instead of tackling one complex task at a time, it can break a problem down into tons of tiny, simple operations and execute them simultaneously. So that makes it really good at handling those massive amounts of visual data that you need for rendering a hyper-realistic video game scene or training a complex AI model.
Okay, that analogy really helps paint the picture. So if we were to zoom in and peek inside a GPU, what's actually going on in there at a hardware level?
So if you could zoom in, you would see thousands of tiny processing units. NVIDIA calls them CUs, or cores. AMD called them stream processors.
Okay.
But think of them like those specialized line cooks we were talking about.
Right.
Each one is pretty basic on its own, but together they create this really incredible parallel processing power.
It's like this massive coordinated dance happening at a microscopic level.
Right.
But all those workers need instructions, right? And ingredients to work with.
Well,
where does that come in?
So that's where we get VRAM, which stands for video RAM.
Okay.
It's the GPU's dedicated memory, and that's separate from your computer's main RAM.
Gotcha.
Think of it like that super fast pantry right next to the line. Cooks stocked with all the graphical ingredients they need, textures, colors, lighting information, all that good stuff.
So the faster the VRAM, the faster those cooks can grab what they need and get to work.
Precisely. And, just like your computer's RAM, there are different types of VRAM.
Okay.
Nowadays, you've got GDDR6, and then you've got HBM2, which stands for high bandwidth memory. But they're all about speed and efficiency, making sure the GPU never has to wait around for data.
Got it. So if I'm a gamer or somebody who works with 3D modeling or video editing, I should definitely be paying attention to what kind of VRAM is in my GPU.
Absolutely. The faster the VRAM, the smoother your experience will be, especially when you're dealing with high-resolution graphics or very complex scenes. You won't see as much lag or stuttering.
Makes sense. Okay, so we've got these thousands of cores all working in parallel.
Yes.
Super fast memory keeping them fed. But how does this all come together to actually create the image we see on the screen?
Right.
It still seems a bit like magic to me.
Well, it's actually a very structured process called the rendering pipeline.
Okay.
And the explainer describes it as like an assembly line for pixels, which I think is a great way to visualize it.
Okay, I'm intrigued.
All right.
Walk me through this pixel assembly line. What are the main steps?
So it all starts with vertex processing.
Okay.
Imagine you have a 3D model of, say, a car. Vertex processing figures out where all the points or vertices of that car are located in 3D space.
Okay.
It's like taking a blueprint and plotting out the coordinates for every curve.
So it's laying the foundation.
Yeah.
Getting everything positioned correctly.
Exactly.
What happens next? So we've got our 3D car model all mapped out in space.
Right.
What's the next step in bringing this thing to life on my screen?
Okay, so next comes rasterization.
Rasterization.
Yeah, and that's where the GPU figures out which parts of the car are actually visible from the viewer's perspective.
Okay.
And then it converts those shapes into pixels, the tiny squares that make up your screen.
So it's like taking this 3D blueprint and flattening it onto a 2D grid, deciding which pixels need to be lit up to represent the car.
Exactly. It's kind of like those paint by numbers kits.
Yeah.
where each pixel is assigned a number that corresponds to a certain color, but instead of numbers, the GPU is using complex calculations to determine the color, the lighting, and the texture of each pixel.
Wow, that's pretty intricate.
It is.
So how does the GPU figure out all those details for each pixel?
Right.
Is that where those CUDA cores and stream processors come back into play?
Yeah, you got, this is where we get to pixel shading.
Pixel shading.
So each of those tiny processors is assigned a handful of pixels, and they crunch the numbers to figure out how those pixels should look.
Okay.
Based on things like the car's material,
Yeah.
the lighting in the scene, the viewing angle, all that good stuff.
So if the car's supposed to be all shiny and metallic,
Yeah.
the GPU calculates how light would reflect off its surface and then tells those specific pixels to light up accordingly.
Precisely. And this is where things get really interesting, because modern GPUs can handle incredibly complex lighting and shadow effects,
Okay.
like ray tracing, for example.
Oh, yeah.
Which is becoming really popular in video games and movies these days, simulates the way light actually behaves in the real world, bouncing off surfaces, creating those realistic reflections and shadows.
Right. I've heard about ray tracing.
Yeah.
It's supposed to be super realistic. But I guess it also takes a lot of processing power.
It does, which is why older GPUs often struggle to handle it. But newer GPUs are being designed with dedicated ray tracing cores.
Oh, wow.
Specialized hardware that's optimized for these complex calculations.
Yeah.
It's like having a team of mathematicians on standby just ready to crunch those light-bending equations.
That's amazing. So we've gone from positioning our car in space to figuring out which pixels are visible, and then to giving each pixel its own unique personality based on all sorts of factors.
Yeah.
What's the final step in this pixel assembly line?
So the last step is output merging, and that's where all those individually shaded pixels are combined together to create that final frame that you see on your screen.
So it's not magic. It's millions of tiny calculations all happening in parallel thanks to the GPU's processing power and clever design.
Yeah, it's pretty amazing.
It is, but you know, we've been talking a lot about graphics and visuals.
Right.
But I know that GPUs are also used for like AI and machine learning.
Yeah, definitely.
How does that fit into the picture?
That's a great question. It might seem like a big leap from graphics to AI, but the underlying principle is the same.
Okay.
Massive amounts of data being processed in parallel.
Gotcha.
You see, training a neural network, which is basically the heart of AI, involves doing a ton of math, specifically a type of calculation called matrix multiplication.
Matrix multiplication.
Yeah.
I vaguely remember that from high school math.
Yeah.
But I can't say I understand how it relates to AI.
You don't have to dive into the mathematical weeds.
Okay, good.
The key takeaway here is that these calculations are highly repetitive and can be broken down into these smaller independent tasks.
Okay.
Which, as we've discussed, is exactly what GPUs excel at.
Ah, so it's like those line cooks again, each
Yeah.
handling a small piece of a larger equation.
Exactly.
All working together to get the job done quickly.
Precisely. And this is why GPUs have become so essential for AI research and development.
Okay.
Frameworks like TensorFlow and PyTorch.
Oh, yeah, I've heard of those.
Yeah. Which are used to build and train AI models, are specifically designed to leverage the parallel processing power of GPUs.
So these tiny chips that were originally designed to make video games look better
Right.
are now powering the AI that's changing the world.
Yeah, it's pretty amazing.
That is incredible. But with all this number crunching and heavy lifting, doesn't it generate a lot of heat?
Yeah.
I know my laptop can get pretty toasty when I'm gaming or running demanding software.
Yeah, that's a great observation. All those cores working at full tilt definitely generate heat.
Okay.
It's kind of like a miniature furnace churning through data and releasing heat as a byproduct.
Right.
That's why it's so crucial to have a good cooling system.
Okay.
Fans, heat sinks, maybe even liquid cooling in some cases.
Wow.
To keep things from overheating.
So those whirring fans I hear when I'm pushing my GPU to the limit are actually a good sign. It means the cooling system is doing its job.
Exactly. It's all about finding that balance between performance and heat management.
Oh.
But, you know, speaking of pushing limits, I think it's time we dive into some of the more cutting-edge applications of GPUs.
Okay.
They're not just about gaming and AI anymore.
Oh, I'm all ears.
Okay.
What else are these little powerhouses being used for these days?
Well, for one thing, they're playing a key role in the rise of cloud gaming.
Cloud gaming?
Have you heard of services like GeForce Now or Xbox Cloud Gaming?
Yeah, I've heard of them, but I haven't really tried them out.
Okay.
Isn't that where you stream games over the internet
Yeah.
instead of running them directly on your own computer?
That's right. It's kind of like Netflix for video games.
Oh, okay.
Instead of needing a super powerful gaming PC, you can stream games from these powerful servers in the cloud.
Okay.
And those servers are packed with high-end GPUs that do all the heavy lifting.
So it's like having access to a top-of-the-line gaming rig without having to spend thousands of dollars on hardware.
Exactly.
That's pretty cool.
It is, and it's opening up a whole new world of possibilities for gaming accessibility, and innovation developers can create even more visually stunning and demanding games.
Right.
Knowing that players can access the necessary processing power from the cloud.
That makes a lot of sense. And I've also heard that GPUs are becoming really important for virtual reality.
Yeah, definitely.
I've always been intrigued by VR, but the headsets and the computers that can run them smoothly are still pretty expensive.
Yeah.
Are GPUs helping to make VR more accessible as well?
Absolutely. Just like with cloud gaming, the parallel processing power of GPUs is being harnessed to make VR more affordable and accessible.
Okay.
Standalone VR headsets, which don't require a separate computer, are becoming increasingly popular.
Right, I've seen those.
Yeah.
They look pretty sleek and compact compared to the older VR headsets that needed to be tethered to a giant gaming PC.
Exactly, and they rely on these powerful mobile GPUs to deliver those smooth and immersive experiences.
That makes sense.
These mobile GPUs might not be as powerful as their desktop counterparts.
Right.
But they're incredibly efficient and capable of handling the demands of VR, and they're getting more powerful all the time.
This is fascinating. It seems like GPUs are playing a role in so many exciting areas of technology.
They really are, and it's not just about entertainment either.
Okay.
The same processing power that makes games look stunning and AI algorithms run smoothly is also being applied to some truly groundbreaking scientific applications.
Okay, I'm really curious now, what kind of scientific breakthroughs are we talking about?
Right.
Are these GPUs curing diseases or something?
Well, maybe not curing diseases single-handedly.
Okay.
But they're certainly playing a crucial role in advancing medical research.
Okay.
For example, GPUs are being used to accelerate drug discovery.
Wow.
By simulating how different molecules interact with each other, they're also being used to analyze massive data sets of medical images.
Okay.
Helping doctors to detect diseases earlier and make more accurate diagnoses.
So these little chips that started out as a way to make video games look better are now helping to improve healthcare and save lives.
It really is.
It's amazing how versatile they've become.
Yeah, and it's not just medicine.
What else?
GPUs are also being used to model complex systems like climate change.
Wow.
Simulate the behavior of galaxies.
Okay.
And even design entirely new materials with specific properties.
That's incredible.
Yeah, their parallel processing power is opening up possibilities that were simply unimaginable just a few years ago.
It's mind-blowing to think about the sheer range of applications.
I know, right?
We've gone from pixels on a screen to the building blocks of life and the vastness of space, all thanks to these little silicon wonders.
It really speaks to the power of human ingenuity, doesn't it?
It does.
We're constantly finding new and creative ways to use technology to push the boundaries of what's possible, and GPUs are right at the forefront of that innovation.
This has been an incredible journey so far.
Yeah.
We've covered a lot of ground, from the basic architecture of GPUs to their evolving role in gaming AI and even scientific discovery.
It's been great.
It's clear that GPUs are no longer just supporting players. They've become the stars of the show.
I completely agree. And the best part is we're just getting started as GPUs continue to evolve. I think we're going to see even more incredible and unexpected applications emerge.
Oh, I'm excited to see what happens.
Me too. It's an exciting time to be following this technology.
Absolutely. But before we get too carried away with the future, I think it's time to bring things back down to earth.
Okay.
And talk about something that's probably on everyone's mind, the cost.
Yeah.
All this power and innovation must come with a pretty hefty price tag, right?
Well, it's true that high-end GPUs can be quite expensive.
Yeah.
Especially with all the recent advancements in AI and gaming.
Right.
Demand has been high and prices have gone up.
Right. I've definitely noticed that.
Yeah.
But I also know that there are more affordable options out there, right?
Yeah.
I mean, not everyone needs a top-of-the-line GPU to do basic tasks or play casual games.
Exactly. There's a wide range of GPUs available at different price points to suit different needs and budgets.
Okay.
You don't need to break the bank to experience the benefits of GPU acceleration.
That's good.
And as technology continues to advance, we can expect prices to become even more competitive.
That's good news for consumers.
Yeah.
But even with more affordable options, I think a lot of people are still intimidated by GPUs.
Yeah.
They seem so complex and technical.
Right.
Any advice for folks who are curious about GPUs but don't know where to start?
That's a great point. It can definitely seem overwhelming at first, but there are tons of great resources available online.
Okay.
Articles, videos, forums, where you can learn more about GPUs in a way that's easy to understand.
Okay.
And don't be afraid to ask questions.
Right.
The tech community is generally very welcoming and helpful.
That's great advice, and I think it's important to remember that you don't need to become a GPU expert overnight.
Right.
Just start with the basics, learn at your own pace, and have fun with it.
I couldn't agree more. Curiosity is the key. The more you learn about GPUs, the more you'll appreciate the incredible impact they're having on our world.
Well said. I think we've covered a lot of ground in this deep dive, but before we wrap things up, I have one final question for you.
Okay, shoot.
Considering how rapidly GPUs are evolving, what's your prediction for the future?
Okay.
What new and exciting possibilities do you see on the horizon?
That's a great question, and one that I'm constantly thinking about.
Yeah.
I think we're just scratching the surface of what's possible with GPUs.
Wow.
As AI and machine learning continue to advance, I believe GPUs will play an even more critical role in shaping the future. We're already seeing them being used in some truly groundbreaking applications. From autonomous vehicles and personalized medicine to scientific simulations that are helping us understand the universe in ways we never could before.
It's an exciting time to be alive, that's for sure.
It really is.
And it's clear that GPUs will be right at the heart of all this technological advancement.
Absolutely. And what I find most exciting is the potential for GPUs to empower individuals and communities.
In what way?
Imagine a world where anyone with a smartphone has access to the same level of computing power that was once reserved for supercomputers.
Yeah.
The possibilities for creativity, innovation, and problem solving are truly limitless.
That's an inspiring vision of the future.
It is.
It's incredible to think about the journey we've taken from those early graphics chips designed to make video games look better to these powerful processors that are now shaping the world around us.
It's pretty amazing.
And it's clear that the story of GPUs is far from over.
Well said. I can't wait to see what the next chapter holds.
This has been an incredible deep dive into the world of GPUs.
Yeah, it has.
We've learned about their history, their inner workings, and their incredible potential to shape the future. But before we go, I want to leave our listeners with one final thought.
Go ahead. I'm eager to hear what you have to say. It really is amazing to think about how far these little chips have come. You know, from boosting video game graphics to becoming these essential tools for things like AI, scientific research, and even medicine.
Yeah, it's like they've gone from the backstage crew to headlining the show.
I like that.
But with all this talk about the amazing things GPUs can do, I have to ask about the cost.
Yeah.
I know they can be pretty pricey, especially the high-end ones.
That's true. High-end GPUs can put a dent in your wallet for sure.
Yeah.
Especially with the demand we've been seeing lately.
Right. I've definitely noticed that.
Yeah, but the good news is that there are more affordable options out there too.
So you don't have to like shell out a fortune to experience the benefits of a GPU?
Not at all. There's a whole range of GPUs out there. From budget-friendly models for casual gaming and everyday tasks to those super-powered beasts for professional work and hardcore gaming. And the great thing is, technology keeps advancing, so you can bet the prices will become even more competitive over time.
That's good news for consumers, for sure.
Yeah, definitely.
But even with more affordable options, I think some people are still kind of intimidated by GPUs.
I get it.
They seem so complex and technical.
Right.
Any advice for folks who are curious about GPUs but don't know where to start?
That's a great point. It can feel overwhelming at first. But honestly, there are so many awesome resources available online, articles, videos, forums, where you can learn about GPUs in a way that's easy to understand. And don't be afraid to ask questions. The tech community is generally super welcoming and helpful. There are tons of people out there who are passionate about this stuff and are happy to share their knowledge.
That's encouraging. So you don't have to become a GPU expert overnight.
Yep.
You can just kind of start exploring and learning at your own pace.
Exactly. Be curious and have fun with it. The more you learn about GPUs, the more you'll appreciate how they're powering so many cool things in our world.
Well said. We've covered a lot of ground in this deep dive, from the inner workings of GPUs to their impact on everything from gaming to scientific discovery.
It's been a good one.
But before we wrap up, I'm really curious to hear your prediction for the future of GPUs. What new and exciting possibilities do you see on the horizon?
That's a question I think about all the time.
Yeah.
Honestly, I think we're just scratching the surface of what's possible with these things. As AI and machine learning keep advancing, I think GPUs will become even more essential. We're already seeing them used for things like self-driving cars, personalized medicine, and scientific simulations that are helping us to understand the universe like never before.
It really feels like we're on the verge of some major breakthroughs.
Absolutely. And for me, the most exciting part is how GPUs have the potential to empower individuals and communities. Imagine a world where anyone with a smartphone have access to the same computing power that was once only available to these giant supercomputers. The possibilities for creativity, innovation, and problem-solving are just mind-boggling.
That's a really inspiring vision of the future. It's incredible to think about how far we've come, from those early graphics chips meant to enhance video games to these powerful processors that are shaping the world around us.
It really highlights the ingenuity of humans, doesn't it?
Yeah.
I mean, we're constantly finding these new and innovative ways to use technology to push the limits of what's possible.
And the story of the GPU is far from over. This has been an amazing deep dive into the world of GPUs. We've learned about their history, how they work, and their incredible potential. But before we go, I want to leave our listeners with one final thought.
Oh, okay, I'm all ears.
We've talked a lot about the technical side of GPUs, the cores, the memory, the algorithms. But what really inspires me is the human element behind it all. You know, these chips designed by these brilliant engineers powered by countless lines of code. They're ultimately tools for human creativity and ingenuity.
I couldn't agree more. It's the human spirit. Our curiosity, our drive to innovate, our desire to solve problems and make the world a better place, that's driving all this incredible technological progress.
Whether it is creating those breathtaking virtual worlds, pushing the boundaries of scientific research, or simply connecting people through the joy of gaming GPUs, or helping us to achieve things that we once thought were impossible. And that's what makes this technology so fascinating to me.
It's not just about the chips and the circuits. It's about the potential that they unlock for humans.
Exactly. And as GPUs continue to evolve, who knows what amazing feats of ingenuity they'll help us to achieve.
Who knows?
Yeah.
It's exciting to think about.
It really is. Thanks for joining us for this deep dive into the world of GPUs. Until next time, keep exploring, keep learning, and keep pushing the limits of what's possible.